Okay, I think we can start officially. First of all, hello everybody. Thank you for partaking in our Hugging Face and Gradio tutorial today. We're really happy to welcome Abubakar Abid today. He finished his PhD at Stanford in applied machine learning. He founded Gradio, which was acquired by Hugging Face in last December, where he's now a machine learning team lead. We're super thankful to all of you joining us and also to Abubakar for doing this tutorial. And yes, the stage is yours and you can start presenting. Thank you a lot.
Awesome. Thank you so much, everyone, for coming today. So I'll be talking about today. I'll be talking about the Hugging Face Hub. So Hugging Face is known primarily for open source libraries, and the open source libraries allow you to build these machine learning models, but then also to share these machine learning models on the hub. And so for those of you who may have not have used it, or maybe you've seen the hub but haven't seen kind of explored all of the different features, I'll start by talking about what the Hugging Face Hub is and kind of what it can be used for. And then in the second half of the talk, I'm going to change gears a little bit, and I'm going to talk about Gradio, which is one of the open source libraries now that's part of Hugging Face's ecosystem. And that'll be more hands-on, and kind of we'll actually build a machine learning demo together in Python. And so that part, I'll share a Colab notebook, and we'll kind of work through that. But throughout any of this, if you have any questions, feel free to just ask, unmute yourself, just ask, or if you can put your question in the chat, then I'll try my best to answer it as well. So, okay, perfect. So let's go ahead and get started. So everyone can, just to confirm, everyone can see my screen here?
Yes.
Yes, we can.
Wonderful. So I'm going to start off by giving a quick NLP example to kind of motivate why we built the hub. So let's suppose you want to actually build a new summarization model. Okay. So you want to be able to take in news articles and then summarize them so that they can fit in the length of a tweet, or that that you have a single sentence so that you can build like some sort of news feed or something like that. So this is a very classic machine learning problem, and if you were to go about doing this the traditional way of doing machine learning, first you would need to collect and clean a data set. So you'd have to scrape all of these websites. Maybe you'd have to find some place where you can get the original articles and their labels. Then you need to actually then pick a model. So you'd have to find some sort of model. Then you train it on the data, you evaluate it, and you keep training until you have a satisfactory performance. All of that can take time and compute. And so, kind of the motivation for building the hub was, well, let's take a look at how the software ecosystem in general does it. There's a lot of reuse and recycle of code. But when we started the hub, there wasn't that much in the machine learning ecosystem. A lot of people were building their identical machine learning models, or very, very similar machine learning models from scratch. There wasn't really a lot of sharing going on. And so we wanted to build something that would allow people to collaborate more easily while keeping everything open source as well. So that's why we built the Hugging Face Model Hub. And so the way that the Model Hub is kind of started off in NLP, now it covers all of these other domains as well. But the idea behind it, and I think what I'll do is I'll just open it up on my browser rather than showing you screenshots, is the idea here is that you can actually find all sorts of machine learning models that you can then reuse and kind of reuse or fine tune, continue training for yourself. And so let's take a look at some examples here. On the left here, you can see that the Model Hub supports all sorts of different machine learning models, not just NLP, but for the purpose of this talk, we'll just focus on NLP. Does someone want to give me a NLP task, like one of the tasks that's mentioned here?
Maybe sentence similarity.
Okay, that's an interesting one, actually. Sentence similarity is an interesting one. So let's click on sentence similarity. So when you click on one of these, what ends up happening is that you filter by these models that are designed to do sentence similarity, this particular task. And so there's 608 such models on the hub right now. And when you see these, you can actually, they're automatically sorted by most download. So, probably like the ones that are downloaded the most are the most useful, but not always. So you can kind of take a look and you can click on one of them. And when you click on one of them, what you're instantly greeted with is you're greeted with a model card. So the model card is a very critical part of the machine learning kind of reproducibility and kind of this open source ecosystem. Because it's kind of like a GitHub README. If you find a GitHub project that doesn't have a README, you're probably going to be a little bit suspicious. You're like, can I use this? Can I not use this? Similarly, with a model card, it tells you exactly, how to use it, what the usage looks like, what the background is, and oftentimes it includes some evaluation results as well. So you can see here, this is what it was evaluated on these various things, and kind of what the process was. Now, in addition to that, you'll notice that for almost every single model type on the hub, include an inference API widget. And the cool thing about this is that this allows you to test the model immediately on the hub itself. Right? So basically, you can just type in your input data, and you can just run the model. And you can see here, like in this case, like this is a happy person. Let me try to compare this to these 3 sentences and see what the similarity looks like. Clearly, this is a very happy person, comes out very high. Now, this is very important because you can understand, failure points of the model. Like, will it work well on this? Will it not work well on this? So just to test this, we can see this is not a sad person. So let's compute this. Okay, you can see here, not bad. It actually did a decently, similar job computing this sentence, but maybe not as much as we wanted. So this can help us understand the model and like immediately try it out. On top of the model card, so one thing that you should know about these model hubs is that they're basically all Git repos under the hood. They're Git LFS repos, so they can store large files as well. So when you look under the files and versions, you can see kind of what the files that are part of this model are. You can see both that it includes a PyTorch version as well as the TensorFlow version. And in this case, it's linked to various preprints as well, so you can kind of see those. You can see those too. You can view the paper and so on. And then finally, there's something that we recently started, which is a community tab as well. So what this allows is for people to discuss the model. In this case, there isn't really much of a discussion going on, but in some cases, there are extensive discussions around models. There are also pull requests because under the hood, this is all just a Git repo, so models can be updated, they can be versioned automatically, and so on. And then finally, if you want to use this locally, there's also kind of the instructions to do that as well. So let me pause here and just quickly ask if there's any questions about what I talked about.
For to avoid having some background noise, we muted everyone. So feel free to write questions in the chat during the presentation.
Yeah, should you have any questions, just put them in the chat, and I'm gonna read them out. Thank you.
All right, thank you. So I'll give maybe one more example of another task. Let's pick another NLP task. Now let's just do translation. Okay, so in this case, there's more than 2,000 models for translation. And they're for various different languages as well. So I can, let me click on, this one looks like it's from Chinese to English. So you can take a look at this here. Yeah, source group Chinese, target group English. There's a lot of information. There's benchmarks, there's evaluation results, and so on. Not too much other information on this one, but again, you can actually test this model out. And I can't read Chinese. I don't know if this is correct or not, but this is you can try out the model here. You can type in your own stuff as well and just immediately check it out. This one does have some discussion going on. People have made a pull request to add the TensorFlow weights, so this is actually really nice. People from the community or from different places are creating pull requests to improve the model. Okay, cool. All right, any questions about this before I finish talking about models? I will mention that you can also see other information about a model as well. So suppose you want to take any of these models and you want to know something about their carbon emissions. So we have that information for a lot of the machine learning models, and you can see that. There's also auto train, which is something that allows you to train the model automatically on your own data if you're interested in that. So a bunch of models are compatible with that. And then you can filter by a lot of useful things, such as what library is written in. So it's not just PyTorch, TensorFlow, Transformers, but a bunch of other libraries also kind of have their models up on the hub. And then you can also filter by like data sets. So maybe I want to know what models were trained on the glue data set. Okay, in this case, maybe not many, but let's, oh, actually, you know, the reason is I think I'm filtering by something else at the same time. Let's go back to the tag list. Okay, auto train, let me get rid of that. Yeah, so I can see 410 models that were trained on glue and so on. Okay? All right, any other questions here? If not, I'll just quickly summarize. I'll just summarize the model hub. So basically, at this point, more than 30,000 public models, more than 20 different tasks, 15 libraries, and then also languages, human languages. So of course, a lot of machine learning models are trained in English, but you know that's certainly not always what's the task at hand, and not sometimes the most interesting models are in other languages. So we have more than 180 different like human languages when it comes to machine learning models. So if you have an NLP task in a different language, most likely you'll be able to find a model for it on the hub. And if not, we would love a contribution. I've talked a little bit about the model card itself, the version control, the interactive widgets. I didn't talk about the tensor board hosting, but you can also actually upload when models are uploaded. You can also upload the training metrics, which can be nice. And just see that directly within the within the kind of the web UI for it as well. So you can get a sense for how this model was trained as well as all these other things that I mentioned. Okay, I'll move forward, and I will actually, just to kind of understand how this works, the idea here is let's go back to our new summarization model. Well, you can actually go on the hub and find new summarization models, right? I can go and I can say, well, let me see if I want a summarization model. Let me click on summarization. Maybe I can find something that's specific for the news even. Oh yeah, look, there's this Pegasus newsroom model. This looks relevant. I can try it out. I can download it. I can run it on my own data. And maybe I'll do some fine tuning on either my own data or on the data sets. We'll talk about data sets in just a second. And then once I'm done, I can again put it back up on the hub so that other people can use it as well. And then I can get all of these nice features like the inference widget and so on. Okay. So moving forward, so one thing that, when we released the model hub, a lot of people started using it. A lot of people also wanted to be able to access data sets. So share data sets, access other data sets. And before, like the datasets hub, a lot of this was decentralized. A lot of it was in different places. And so we created the datasets hub to essentially organize this information as well. And so you can see that there's lots of datasets out there, more than 18,000 datasets, again, on a bunch of different categories. I won't go through everything right now, but for example, let's say we pick extractive QA. So the squad dataset shows up. And when you click on it, again, you see a lot of information. You see a preview of the data set, so you can start immediately understanding what does the data set look like. And again, there's a data set card that explains a lot more about each data set. And then you can do things like, for example, see what models were trained or fine-tuned on this data set as well. Okay. And along with that, you can see what languages it's in. You can see how it was created. And again, if you click on any of these, then you can see other data sets that also fit in that category. So what other data sets are of this size, you can take a look at that as well. Cool. All right, let me, again, maybe pause if there's any questions here. A lot of different data sets are out there. More than 450 languages and dialects are supported in the data set. So very multilingual type data set as well. And the cool thing is that one thing I probably should have mentioned earlier is both the Hugging Face Hub, the model hub, and the dataset hub allow you to actually work with these datasets locally as well. So you can import any of the datasets in just one line of code. And then you can actually work with it in kind of a streaming way. So even if it's beyond the size that it can fit in your machine, you can actually train a model on it just because the datasets library handles streaming and everything under the hood. Okay. Any questions about any of that? If not, okay, oh, there's a question here. Yeah, can you talk about how the streaming functionality works under the hood? Yeah. So it's a good question. There's a lot that goes on, but kind of just for the purpose of kind of this talk, let me actually come back to that, because I am actually planning on talking a little bit about that when we talk about demos as well. So let me come back to that. But basically, the TLDR is that it just loads. You can set how big of a buffer you want to load. It'll load only that size in memory, and then as you're training a data set, it kind of just intelligently loads the part into memory that it needs to train, and then it sends it back to disk. It'll load from disk rather than having to fit the whole thing in memory. Yeah. And I will say that it scales very well. So we have right now, it's not just like hobbyists that are using this. Or right now, we have a science team at Hugging Face that is training the largest like multilingual GPT type model. It's called Bloom. And they're using this, it's a 176 billion parameter model on a huge data set. And they're using the datasets library to stream the data set, and it works really, really well. So it's designed for pretty heavy production workloads as well. Cool, let me see if we can. Yes, so datasets is beyond NLP actually. Sorry, that's something I should have clarified. So just like models are beyond NLP, datasets are also beyond NLP. So you can see a lot of the. So let me go ahead and open up different task categories. So we have, for example, image to text. You have this, which I guess kind of is NLP, but you have other things as well. So for example, you have audio classification as a task as well. And so this is, here you have audio, and again, you can preview it right here. You can listen to the audio snippets.
Chapter 16.
Okay.
I might have told you of the beginning of this liaison in a...
Okay, so this is actually an audio to text data set. I guess you can use it for different things here. But it's not just NLP. Let me see if I can, I can, for example, let me just search image. I think it's ImageNet here. But yeah, so we have some versions of ImageNet. Okay, looks like we have various ImageNets, tiny ImageNet, ImageNet 1K. Let's take a look at this one here. Okay, so this is an interesting one here. So some data sets are gated. So the person who uploaded the data set, for various reasons, typically it's because of like certain what's it called? Use cases that they restrict the data set to. So what they do is they require you to like share your contact information for that data set. So in this case, I will go ahead and just access the repo, and now I can go ahead and see the data set. And because if you're logged in with Hugging Face, if you're logged in with your Hugging Face account, that's it. That you don't have to do anything else. You can just see the data set, and you can see what it's used for here. So yes, to answer your question, we are absolutely not just NLP anymore, even though that's where Hugging Face started. In fact, you may have heard we recently acquired Ross Reitman to the team, the creator of the Tim library. So now he's part of Hugging Face, and kind of Tim will gradually get more and more integrated within the Hugging Face hub and the Hugging Face ecosystem. Thank you for the questions. Are there any other questions? I see another question being typed. Oh. Okay. Just let me give like a preview of what's to come then while we're waiting. So I'm going to actually change gears now. So far I've been talking about models and data sets. And those are like the two of the three pillars of machine learning that we think about at Hugging Face. The third pillar is demos, machine learning demos. So I'll be talking about, first of all, why demos are so important and why we think they're just as important as data sets and models, really. And second of all, we'll be actually building a machine learning demo ourselves. And so let me talk about that. Let me go ahead and transition to that as well. So again, if you have any questions about any of the previous stuff we talked about, models or data sets, feel free to ask them. But now we're going to be changing gears a little bit and talking about demos. So first of all, I'm actually curious for the folks here. have you ever built a demo for your machine learning model or tried to build one? That's fine too. I'm curious, like if folks are already kind of interested in building demos or not really. Maybe you can just type in the chat so I can have an idea of it.
We also activated the unmute function, so I hope you can unmute yourself again.
So yeah, great question about adapting. Yes, you can absolutely define a model from scratch. It does not have to be used. It does not have to use any of the transformers models. So you can actually see that. Let me go ahead and share my screen again here. So if you go back to the models that are here. So if I filter by PyTorch, so in this case, many of the PyTorch models are also transformer models, but not all of them. And I don't know if there's an easy way for me to find one right now, but you can absolutely push one, push a generic PyTorch model as well. And I will see if I can find some information about that and kind of just share how it's done afterwards. But it's generally speaking, it's actually, I mean, at the end of the day, all of these models, they're just Git repos. So you can push what you want. And if you want the inference widget, you have to kind of format things appropriately. But at the end of the day, yeah, you can push pretty much whatever you want, and it'll kind of, it'll detect what kind of library it is. It'll show up correctly. Let me see if I can. Yeah, maybe afterwards I'll send a guide over to maybe most of them, and you can share that with the rest of the team as well. Okay. Oh, cool. So Tonito said that you're building a demo with Gradio. Fantastic. Okay, so hopefully you'll find this talk interesting. And for the other folks that are maybe too shy to say, I'm guessing that many folks here maybe tried, and at some point, they're like, okay, it's a little bit too complicated, because traditionally it has been quite complicated to build demos, as I'll talk about. But we're hoping to simplify that a lot. But anyways, first of all, so why are machine learning demos so important? So essentially, kind of as far as machine learning demos go, I think the way we think about it is there's three big reasons why you should build machine learning demos. First of all, it's kind of the obvious one. You get to present your work to a wide audience, right? Now, if anyone has wrangled with a GitHub repo full of code to try to get a model to work, they know that it's not easy for people to actually try to use machine learning models, even if the code is released, and so part of it is kind of accessibility and reproducibility. If you release a demo, anyone can try out your model, even if they just can open up a GUI or open up a browser window. It allows you to easily present your work to a wide audience. So this is important. Increasingly, machine learning is an interdisciplinary endeavor. So you might have other people, that let's say you're building a model for the business team at a company, or maybe you are doing like what I used to do, which is machine learning in medicine, and you're building models for clinicians or doctors. And so increasingly, like the consumers of machine learning models are a lot of people who might not be machine learning engineers. And I think the recent viral demos with like DALL-E Mini and all these various ones kind of reinforce that. A lot of people are now using machine learning models. It's not just machine learning engineers. And so you want to be able to get your model in front of these people. The second kind of point here is that one very important reason why at Hugging Face we think demos are very important is because a lot of machine learning models have biases and failure points. And sometimes it's not really possible for the machine learning engineer to know about all of the different ways that a model can fail. I mean, that's just not realistic. And so creating a demo where diverse people can try out the model and understand what's wrong with the model and maybe flag problematic data is really powerful. And so I think that's why we encourage a lot of people to build demos so that we can actually build better and better machine learning models. Okay, so a lot of times, when I've talked to people, when I've talked to people about building machine learning demos, what I hear is I was interested in building a demo, but then I realized I got to learn all of these different things, Flask, Docker, these web scripting languages, and then it's like I'm good, I actually don't need a demo. And it's true, kind of the traditional old way to build a machine learning demo was required you to know not just a lot of different frameworks, but a lot of different languages, right? You needed to know Python to train the machine learning model, but then maybe SQL to store the data coming in, some web scripting stuff. And so we wanted to make it a lot easier to do all of that. And so we built the Gradio library in order to do that. And the Gradio library is not only is it just one framework, but the idea is that it's written in Python, which is a language you already know if you're building a machine learning model. And the cool thing is with just a few lines of code, you can build all sorts of different demos. I'm showing a couple of non-NLP examples just to show how kind of diverse Gradio is, or the demos that you can create with Gradio are. But you can use it for NLP as well, of course, as I'll show in a little bit of time. So for example, I'm just going to show a couple of examples of Gradio demos. So this is one for Jojo again. So this is a model that takes in an image and it renders it in kind of this cartoon style. And so you can drag and drop your own images. You can even select what kind of animation style you want. In this case, Disney is chosen. And you can see kind of the output looks something like this. So going back to news summarization, which is the example that we started this whole conversation with, you can put in, for example, your own news articles. You can see what the output is like. You can do all sorts of things here as well. This is one that was recently released by Microsoft. This takes in 2 audio inputs, so you can actually record 2 audio files, and it tries to predict whether the people who are speaking are the same people or different people. And so this is used for like voice authentication on your laptop or in your phone or something like that. Okay, and so before I go into kind of the technical pieces, actually I'll just quickly mention this part. And kind of the idea behind Gradio is we wanted to make it as simple as possible to create these demos for your models. So typically in 3 lines of code, you can go ahead and create a Gradio user interface or Gradio UI. All you really do is you import Gradio, then you pass in the function that you have, and then kind of the list of inputs or outputs that correspond to that function. So in this case, I can say, okay, I want the input to be a drag and drop image, I want the output to show labels, and then a function that kind of maps the input to the output, that's it. And then Gradio kind of takes care of everything else. Okay, and we'll talk about that. And the cool thing is that you can also go ahead and host any Gradio demo for free on Hugging Face Spaces. So just like we have models and data sets, we also have spaces, which is what we call demos at Hugging Face. And you can kind of see that these spaces allow you to do a lot of different things, including, for example, let's see if I can find DALL-E Mini as well. Yeah, so DALL-E Mini, which I'm sure many of you guys have seen, is a Hugging Face space that's hosted here, built out of the Gradio components. Cool. All right. Any questions? Oh, actually, yeah. One other thing I will mention is kind of with DALL-E Mini and with many of these other machine learning models like AnimeGAN, we're seeing a tremendous increase in the number of people who are able to actually try out machine learning models. So this is AnimeGAN, also one of these models that convert an image into this cartoonized version or this kind of like sketched version. And so when we released it, it went viral. A lot of people started using it, got a lot of traction. And what this has led us to kind of understand is that we're really at a kind of historically, I think this is the first point where it's not just hackers or engineers that are using machine learning. Really, anyone who can use a GUI or a browser can now access state-of-the-art machine learning, which is very exciting. And so we're hoping that opens up a lot more possibilities, a lot more use cases. People keep in mind that so many people can use their machine learning models, so people build better, more robust models. And with that, kind of the last part of this talk that I have is actually us going through and building a Gradio demo ourselves. So before I dive into that, and that's a little bit different because I'll share a Colab notebook with you guys, does anyone have any questions about demos, anything I've talked about so far?
I guess it's worth mentioning that. Can you hear me, by the way?
Yes.
That spaces also support GPU, and then if you have more like advanced applications, you can allocate GPUs and run them, and it's really a great place to show. And actually, it was on the cover of New Yorker recently, the Gradio demo. So I guess it's also worth mentioning that.
Yeah. Yeah, that's true. That was actually very, very cool to see. I think DALL-E Mini and these demos generally, I think, they allow machine learning to kind of penetrate society in a way that has never really been possible before. And I think DALL-E Mini was a great example of that. AnimeGAN was a good example before that. And I'm sure we're not done with seeing viral machine learning models. We'll see more and more of that. To go back to your question about GPUs, Yes, so it is possible to get GPUs. So we have a limited number of GPUs that we provision for spaces. And basically, the way to get it, there's two ways. If you build a public space, then and it gets starting to get traction, we'll automatically assign it a GPU so it can handle load and stuff like that. If you build a private space, well, you can build private spaces for free, but if you want private spaces with GPU, there's a paid offering there. And if you have more questions, you can ping me about that afterwards. Yeah.
There was another question.
Yes.
What do you think of PyScript and its future?
Yeah, so this is a really good question. I've been paying, I think I've been looking at PyScript a lot because I think it's very exciting. I mean, of course, being able to write Python in the browser is very exciting. So I think PyScript approaches the other way, which is rather than writing Python, which produces web apps, you're writing Python within the web app itself. I think it has certain advantages, like being able to have one file where everything is running. However, all of the examples that I've tried so far are extremely slow, because essentially the Python has to run in the browser as well. So I think there might be certain niche use cases where maybe there's a little bit of data that needs to be very tightly coupled with some processing logic where it makes sense not to have some backend server. But I think in most cases you want the heavy lifting to be done in the backend on a server, not in the browser. So I think it's going to be very useful for certain niche use cases, but probably not kind of as a general purpose tool. Martin, democratization of ML, yes, that is what we're going for very much at machine learning at Hugging Face. Cool. So great questions. What I want to do now is I'm going to go ahead and share this. Well, let me open this up. So what is this here? So this is a Colab notebook that I've put together. And what this does is it kind of goes through some common kind of use cases, some simple examples of using Gradio. So I'm going to go ahead and share this with you guys. I'm going to share it inside the channel. And what I'd like to do is for us to kind of go through this Colab notebook together. That way you guys can also edit the code, tweak certain things, and see how see what happens, when you change the code. And if anyone hasn't used a Colab notebook before, it's just text and code, and then you can run the code just by going into one of the cells and pressing Control Enter. So, can you guys confirm that you're able to just even open up the Colab notebook?
Yes, seems good.
Okay, great. Yes, perfect. All right, great. So go ahead and open it up, and then we'll start by going down to this cell here, pip install Gradio. This will just go ahead and install Gradio in this Colab environment. So Gradio is an open source Python package, so you can just pip install it wherever you do Python. So you can do it in a Colab notebook, you can do it in your local environment. And then we'll get started. So basically Gradio has three ingredients. I mentioned this before, but I think this is a key thing to mention. So it has one core class called the interface class. The interface class basically defines a user interface. It takes in three parameters. The first is a function. The second is what kind of input I want. And the third is what kind of output I want. In this case, I have my function is called sepia. And all it does is it applies a sepia filter to an image. So the image is like a NumPy array. It multiplies it by a matrix. And that, this is essentially applying the sepia filter. And so the input here should be an image, of course, because I want to be able to drag and drop in my own images. In this case, the output is also an image. It doesn't always have to be this case. Sometimes the input could be, oops, I forgot to run this. Let me run this cell here. And then sometimes the image could be, input could be text and the output could be an image, or it could be a lot of different things, as we'll see. This is a good one to start with. So when I run this code, when I define my function and I run this one line of Gradio code, really, what happens is that an interface is created here. Okay, you can kind of see that. You can kind of see this user interface here. And what this allows me to do, I can upload my own images here. So I'm going to go ahead and upload an image, and I can run this, and I can see what the output is from my function. Right? You can see all that Gradio is doing really is it's creating this UI wrapper around my function. Okay, it's very simple. But it's also very powerful because this function can be anything, right? This function can be your machine learning model's predict function. It could be an API call. It could be whatever you want. And Gradio will handle the processing in order to convert this image into an appropriate format. So by default, images are converted to NumPy arrays. But if you want, you can actually change that as well. You can change it so that it gets sent pre-processed as a file path or as a PIL image, and whatever makes sense for your function. And then the output, in this case, it realizes that, oh, this is a NumPy array. I have to convert it to an image. But again, if you want to change that, you can also, or in this case, if you return a file path or whatever you return, it'll automatically recognize that and it'll render the image appropriately. All right. Any questions about this first example here? Right, if you haven't, feel free to also just try out this image or just run this code as well. In fact, you can, if you want, you can even try changing some of the code. What happens if I change this function, I can rerun it. I can easily create another an interface around it. I can see if there's anything interesting that happens here. Okay. Oh, interesting. Still seems to do something like a CPO filter.
Yeah, you are doing the diffusion process manually.
Oh yeah, right. That's true. So one thing I do want to mention is that when you create one of these interfaces, and inside the launch function you write share equals true, or you're running in a Colab notebook. But in a Colab notebook, this happens by default. Is that a public URL gets created? Okay, but this is really powerful because a public URL essentially allows me to take this demo and share it with the rest of you guys. I can share it right now in the chat, and any one of you guys can open this up and try it out in your browser. Okay, you can try it out in your browser, and what's going to happen is that your browser, the code isn't going to run in your browser. It's not like PyScript. What happens instead is the model gets sent back. Sorry, the data gets sent back to wherever the code is running or where the model is running. It gets processed and then it gets sent back. And so the cool thing about this, there's two cool advantages here. One is super fast. Like, the code continues running in the same environment, so it's very fast. It doesn't slow down your browser or anything like that. And two is because the code continues running locally, you don't have to worry about packaging anything or deploying anything. Instead, all that's deployed is a UI to your model, and then Gradio handles all of the message passing back and forth. And so again, this works with the simple example, but it'll work with any example. So let's say you have a machine learning model that you've trained, just launch it and just set share equals true, and now you have a link you can send to your collaborators, to your customers if you want to let them try out what you're building, and the link will run for 72 hours. Yeah. And again, if you want a permanent hosting, then you can use Spaces for that. But then you have to kind of like package everything and deploy it. Yeah. Okay, let's see one more example here. This is a little bit more of a complex example because now we have a function that takes in 3 parameters. But that's fine. If you take in 3 parameters, you just pass in 3 inputs instead of 1. Okay, and you pass in a list of 3 inputs specifically. And so you can see here the first one is a drop down that we've defined, which is like a musical note. The second is which octave we want. And the third is what number we want. How many seconds duration. And what this does is it passes those in as the parameters of this function. Everything gets mapped intuitively. Drop down gets mapped to note, octave gets mapped to slider, number gets mapped to duration, and then it runs the code, and then I can see it here. And so let me run this. So it kind of runs this. And again, same thing. I have a public link here. You guys can run it locally on the Colab notebook, or you can just try it out here. And share it here. Yeah. All right. So there's some questions here in the chat as well. Okay. So yep. So most of them tried it out as well. Leona said that when she tried to submit an image in the link, it says error. Really interesting. I wonder if the format of the image is a little bit different. We can, maybe try a different image and see if it's still giving you a problem. It should work. And there's a question here, can we put the sample on an HTML page or in a markdown README? Do you mean can you embed this Gradio demo inside an HTML page? Or
I
what do you
guess, I guess it means embedding HTML
embedding.
iframe. Yeah.
Yeah, so absolutely. So if you are hosting the model up on Hugging Face Spaces, you can absolutely embed it. In fact, I have an example of that down at the bottom. I was going to talk about that at the end, but I'll just talk about it now. Example here, I have a on Hugging Face Spaces. This is a model that basically is like a sketch recognition model. I'm just kind of draw something, try whatever. And kind of recognize what you're drawing. And now what it can do is you can actually just embed it as an iframe. In fact, there's two ways to embed it. One is using an iframe. The other is using web components. But regardless of how you do it, it shows up in kind of a nice way here. And then you can, like, for example, let's say you have a blog post. You can write a blog post with an embedded Gradio demo right there, and people can try out your machine learning model by the time they, reach the end of your blog post. So that can be really powerful as well. Okay. Cool.
I guess you can continue when the error message is here. We can then discuss the nature of the error.
Absolutely. Yeah, sounds good. So kind of the other thing I just wanted to mention is kind of tying everything together. So we started talking about, I'm just going to close this, yeah. Models up on the Hugging Face hub, right? And now we're talking about demos. One of the cool things is that for any model up on the Hugging Face hub, I can load it and use it as a demo. So for example, let's take a look at this one here. So this is a model up on the hub. Let me just go to it. So this is a speech. Everything's open, but yeah. So anyways, it's a text-to-speech model. It's been used 7,000 times. It's just kind of one that was released by Facebook. And let's say I want to build a demo around that or using that. So what I can do is I can do gradio.interface.load. Oh, there's some background noise. But yeah, that's okay. So and then I just type in Hugging Face / the path to that model. So Hugging Face / the path to that model. And what that does is it loads that model up from the hub, and now I can start using it. So for example, let's say I say something like, I'm teaching a machine learning class. And so what's going to happen is it's going to take this and it's going to send it back through the kind of to the Hugging Face hub and run through this model and get a prediction out. Oops, there seems to be an error here. I will take a look at that. It could be sometimes these models can be down. So let's just try another one here. GPT-J here. So this is a 6 billion parameter model. And it should be able to do language. Okay, yeah, so this one is working. Okay, so this one, let's say I'm teaching a machine learning class. We can see how it is, it completes it. It completes it here. And again, because this is running in a Colab notebook, a shareable link has been created. I can share this with you guys as well. And the cool thing is you should be able to load pretty much any model off of the Hugging Face hub and then adapt it to your needs. So if you want to pass in a couple of examples, you can see how I've passed in the examples here and how they show up down here. And you can do this with other things as well. Okay, I can add my own title, I can add my own description and stuff above the model too. Okay. Any questions about loading models from the Hugging Face hub? Okay, so Leona, did you drop your own image first? Did you try putting in your own image?
I tried it, and it says error when I submit it empty.
An error if you submit it with an image and if you submit it empty? Because if you submit it empty, I can see why there'd be an error. But
for me it works, but I don't know, maybe she didn't upload the image successfully because it says the same error message when I submit empty when I just click on submit.
Exactly. So I think that's the issue here. There was no image that was actually submitted.
I guess you can just click on the link here now and show.
Okay, all right. It looks like it's out here. Yes. So a good question from Ariel here. When you use the Hugging Face model as a Gradio demo, is this an API called Hugging Face? Yes, exactly. That's what it is. So that's why it's so fast and there's no download processes or anything like that. You can also, of course, use. You can also kind of download a transformers model or any of the models from the hub locally in that Colab environment, and then you can essentially kind of use it. Let me show kind of an example of this from the Gradio docs. So one thing that you can do. So yeah, by the way, the Gradio website, the Gradio repo, the Gradio GitHub repo is gradio.dev, and the shortcut for that. Let me go ahead and share that here, in case it has a lot of the documentation and stuff. So share that here if you want to check that out. But the documentation is gradio.app/docs, and so I'm going to share that with you guys as well. And it shows different ways of actually loading an interface. The classic way is by providing a function inputs and outputs, but you can also load. Sorry, not this. Yeah, you can load one by providing the Hugging Face repo, or you can load one from a pipeline object. So if you guys have used the Transformers pipeline abstraction, you know that supports a lot of different kinds of models, and you can essentially. So for example, in this case, we have an image classification pipeline. You can just load it from the pipeline, and in that case, it's going to be running locally, not using the API. So let me go ahead and share the link to the docs as well. Other questions here? I'm going to go back and I'm basically going to wrap things up here. I already talked a lot about these other things, which is hosting the demo for free on Hugging Face Spaces. If you're interested in trying this out, you can kind of follow these instructions. I won't go through it just for the purpose of this talk here. And then once it's up on Spaces, you can do cool things like embedding it in different places, like we talked about, and so on. So with that, I'm going to go back to the slides real quickly here. I think that's pretty much the core material I wanted to cover. Let me see if there's anything else here. Apologies, I think it's too much. Let's take a look here. Things are loading a little bit slow. Yeah, if you have any questions. Yeah, awesome. I think that was the last piece. I think that kind of concludes the presentation that I have. If you have any questions for me, I'll share I think Twitter is probably the best way to reach out to me after this talk. So I'll share that here as well. Okay, and then if there's other questions, I'm happy to answer them. So great question by Silent for Pin here. So and button functionality work. So okay, you may have seen that when we launched the Gradio demos, there was a flag button as well. So what that does is it essentially, okay, so the purpose behind that is to allow people to test your model and flag samples that are a little bit problematic for any reason. So what that does is when someone tries out the model and they click the flag button, that data point gets saved wherever the model is running. So let's say you build an image classification model, or let's say even a text summarization model. You try something and it doesn't work well, you can click flag and that sample gets saved to a CSV file, kind of the model creator's computer or wherever the model is running. You can use that to add samples that are problematic, and then the model creator can do things like, for example, retrain on those samples or understand why those samples are failing and so on. And so it's designed kind of an easy way to collect a lot of like potentially problematic samples. know if that makes sense. So yeah, but good question, Silent, beforehand.
Thank you very much for a great talk. I'll also have some questions, if it's okay. So going forward, what's your vision for Gradio library as a whole? And then my second question is that with this recent community tab in Hugging Face, is there also a plan to do a contribution style, like contribution map, like in GitHub, to add in the future in the roadmap somewhere or not? Because I mean, I see a lot of people doing a lot of demos, but when you click on the profile, you can't see any like contribution timeline, let's say.
Yeah, it's a great question. So I can answer the first one for sure. So the plan for Gradio going forward. So the plan for Gradio is now actually to build more and more complex types of web apps. So what we're seeing is there's an interest in people using Gradio not just to build these simple kind of machine learning demos, but also more complex web apps. And so we've recently introduced something called blocks, which allows you to do things in a more flexible way. So I didn't really get a chance to talk about it because it's beyond the kind of the scope of this conversation. But you can build much more custom web apps where you can align things, you can position things on a page, you can have rows, columns, you can attach event listeners and all of that directly from Python. And we're seeing that used to create a lot more sophisticated machine learning demos. So that's been pretty exciting. And we're planning on making this more kind of like just more and more versatile, so you can build more kinds of web apps with Python. We're also looking at potentially some integrations with PyScript as well. So that's kind of in the early stages of brainstorming that. Let's see what else. And to your and then kind of also getting into more other areas of machine learning. So for example, reinforcement learning and so on. We're looking at that as well. And then finally, like one thing that we're looking at is handling bulk data. So right now, as you can see, like Gradio is mostly designed just for like one-off sample inferences. But what if you want to work with a batch of data and just get a batch of responses? It's kind of a hassle to do that with Gradio right now. So thinking about how to enable those kinds of use cases. So that's kind of the first question that you asked. The other question you asked, which is contributions. Yeah, so definitely I think we're seeing a lot more. We're seeing the community tab being used a lot. And we're still figuring out how to best handle like the PRs and the contributions. And so that's super active area of feedback. And development. So if you have more ideas like that, let me know, and I'm happy to pass on this feedback to the folks that are working on that. Yeah.
Thank you very much for the answer, and thank you for touching on the topic of Gradio blocks. Actually, people can go check Gradio blocks party. There are some really creative spaces which has been built, and I guess if you show one or two, it may be an inspiration for some listeners here. Because I also took part in that event, and actually there were really pretty good teams there.
Yeah, absolutely. So this was
you can show the
amazing.
winner. Yeah.
Yeah, exactly. So kind of you've seen like the Gradio demos that you can build with interface, but you can build a lot more complex ones with blocks. Let me see if I can find which one was the. Anyways, let me just pick one of them. Or let's go to that. So
because
for example,
you can sort by likes and then.
Yeah.
Where's
that?
Oh
yeah, there it is. Yeah, awesome. Thank you.
That's okay. It's okay.
Saying this. Wait, no, it's not quite doing it.
Oh no, it's because some people pin their spaces. You can expand.
I'm gonna try. Yeah, it's okay. Well, it doesn't. It's fine. But you can see here, people, with blocks. So all of these demos, so like what most of them is alluding to, were built with blocks. So the more kind of flexible, low-level API for Gradio. Things like tabs being here. You can see a lot more kind of complexity here. I'm gonna try to go onto a different one actually. Dual style. Let's do dual style again. More example here. Well, it's let me. It's fine. Let me just pick maybe a different one here. Let's do. This one. I don't even know if this is. Oh, okay. Take a look here. Yeah, so you can see here people building like just kind of just images, a little chat bot here. Anyways, a lot more flexibility, and you guys can check this out afterwards. I'll share the link, and you can kind of get that flexibility with blocks. So, yeah, thanks for suggesting that. So, let me share the link. Perfect. Yeah. Again, if you have any other questions even after this conversation, feel free to reach out to me on Twitter. That's probably the best way, or email as well. I'll put down my email as well. And thank you so much again for coming and listening.
Just just a few questions. First of all, can I just share the Google Colab notebook in our Discord so people can just play around, even people that weren't part of the talk?
Absolutely. Let me go ahead and share that collab note. Oh yeah, you already have the link to that, right? Yeah.
Yeah, I have it. It's working. I'm just gonna share it in our Discord so people that weren't able to join can just play around and yeah.
Definitely, of course.
Also, Muhtasham basically asked a more general version of my question that I had. It was about, in the beginning, you mentioned that you have over 180 languages, and I suppose that your answer to my question would be the same. I would just wondering about contributing to languages, especially like less represented languages or languages that need improvement. So yeah, I guess, yeah.
Absolutely. So we're definitely trying to work on improving. There's always going to be low resource languages, and we would love to have more data sets, models that are trained on those languages. Basically, everything is community based. So if there's a language that you know or you're interested in working with, and let's say you have a particular model that you have trained, you can go ahead and you can upload it. If there's someone, the Hugging Face Discord, which I had a link to at the very beginning of the talk, is a good place to discuss these things as well. I know that in the past we've had like specific community sprints dedicated to improving our like low resource language coverage. So that the Discord is a good place to discuss that, and kind of just people will jump in, and that you might be able to find collaborators or even folks from the Hugging Face team who are interested in helping.
So basically, we can, for example, as you said, open a discussion in the Discord, or maybe just a normal like pipeline of, for example, contributing to documentation or just fixing issues like bugs in the existing code would be a way to start if somebody wants to contribute to like a resource language. Okay, great. Thank you.
So much. Yeah.
Yeah, I guess that's it. If there is no other question, we thank you again. Thank you for your time, and it was really insightful, I guess, for a lot of users, especially for some members who are new to machine learning, and it's easy way for them to handle this. Thank you very much again, and yeah, see everyone next week in the event with Dr. Juice to productionalize transformers. Yeah, thank you very much.
Thank you for organizing this, Mr. Zonover, and all of the team. So, bye.
Thank you. Bye.